Okay, we answer the first question. That is, we should show that the sequence is arithmetic. We say that sequence is arithmetic when the difference between any two consecutive terms is constant or it is same for all the differences. So let's check that. I'm going to consider the A2, that is the second term, and A1. So I find this difference A2 minus A1, and this equals let's designate the terms. This is A1, this is A2, this is A3, and this is A4, and this is A5, that is the fifth term. So let's find this A2 minus A1, and this equals 9 minus 2, and this equals 7. And also let's find another difference, that is A3 minus A2, and this equals 16 minus 9, and this is 7. Let's also find other difference, that is A4 minus A3, and this equals A4 is 23 minus A3 is 16, and this is also 7. Let's find the last difference, that is A5 minus A4, and this equals 30 minus 27, and this equals 7. So we see that everywhere the difference is the same. We say that this difference is represented as d, and this equal to 7. So we have identified that this sequence has common difference of d equals 7. Therefore, we say that since it has a common difference, the sequence is arithmetic. We will now find the general nth term of this arithmetic sequence, which is un. We can also write this as an, and this is given by the formula a1 plus n minus 1 times d, where d is the common difference. We already determined that d equal to 7, which we will utilize when we substitute into this general nth term formula. So let's focus only this equation, that is an, or we can also write this as even. I'm going to write this as an, and this equals a1 is the first term, so I replace a1 by 2 plus n minus 1 times d is common difference. We determine d equals 7, so let me replace d by 7. Let's simplify this. So we get 2 plus, we distribute the 7 into the n minus 1 term. So 7 times of n is 7n, and then minus 1 times of 7 is minus 7. So this simplifies to, I put the 7n first, and then 2 minus 7 is minus 5. So this is the general nth term of this arithmetic sequence. Otherwise, we can also write this an as un also. This is equal to 7n minus 5. So this is the general nth term of this sequence. Okay, let's determine the hundredth term of this sequence. For this, we will utilize this general nth term formula, that is un equals 7n minus 5. Since we want to find the hundredth term, we replace n by 100. So therefore, this formula becomes u of 100, and this equals 7 times of 100 minus 5, and this equals 7 times 100 is 700 minus 5, and this equals 695. Therefore, the hundredth term of this sequence is 695. We now determine if 8000, I'm sorry, it is 828, 2341, a member of this sequence. We determine this by substituting this in place of un. That is, we are given this basically represents u sub n. So we are going to replace u sub n equals 828 2341 into this formula and determine the value of n. Let's see what we get. So I replace un as 828 2341, and this equals 7n minus 5. I add 5 to both sides. So therefore I get 8 to 8, 2, 3, 41 plus 5 is 45, and this equals 7n. Let's determine n from this one. Therefore, we get n equals 8 to 8, 2, 3, 4, 5 divided by 7. And the result of this division is 1183, 192.14. This is approximately rounded to two decimal places. So we are getting this n in terms of decimals, but not as a whole number. Only if we get n as a whole number, we then say that the given number forms the member of the sequence. And since we get n in terms of fraction or decimal, we say that this 8282341, this is not a member of the sequence.